Okay, so hello everyone. My name is Kunal, and I'm your physics tutor, and we are actually doing oscillations. And today is our actually lecture number 12, and actually today is actually our last lecture. So let me quickly recap the thing कि हमने previous class में क्या क्या चीजें cover करी थी. So in our previous class, we actually discuss the vibrations, which is like a free vibration, जिसमें हमने बात करती है इसकी ओमेगा नॉट विल बी लाइक रूट अंडर के बाई एम एंड इसको हम नेचुरल फ्रीक्वेंसी भी बोल रहे होते हैं. देन आफ्टर वी डिस्कस लाइक डैम्प्ड वाइब्रेशन, जिसमें मेनली हमने डिस्कस क्या करी कि इसके एम्पलीट्यूड्स कैसे वेरी कर रहे होते हैं. सो इसकी एम्पलीट्यूड एक्सपोनेंशियली डिक्रीज कर रहा होता है एंड इट वेरीज लाइक ए इक्वल टू ए नॉट ए टू द पावर माइनस pt by 2m, where b is actually damping constant. एंड देन हमने लास्टली डिस्कस करा था फोर्स्ड वाइब्रेशन, जिसमें हमने डिस्कस क्या करी थी. जो मेजरली हमने डिस्कस करा था वो था रेजोनेंस, in which this is basically it is the condition where the amplitude is maximum, right? So हमने यही सारी चीजें in previous class में डिस्कस करी थी. So now in today's class we are actually going to discuss our new topic actually, which is actually termed as superposition of the two simple harmonic motions. So let's start. Superposition of two SHM. So there were actually several cases. So we actually deal this topic as a case wise, right? So let me write the first case. When oscillation or oscillating with, when the both of the wave oscillating with same frequency and in same direction as well, right? So this is actually the case one, in which I am considering that the two waves superpose, or the two basically oscillating motion superpose, in which I'm taking the first case as in which the two of the motion have same frequency and both are actually oscillating in the same directions, right? So let me write here the equations actually. So actually let us assume that the motion is in x direction. So I'm gonna writing here x1 is equal to a1 sine omega t. And since the frequency, since the both of the wave have same frequency, so we are using the same omega for the other one also. And x2 is equal to a2 sine omega t. And let us assume it has some phi as a phase difference, right? So these are the two actually equation of simple harmonic motion. And I am considering that if these two of the motions superpose each other, in which I'm considering, I'm again telling you, in which I am considering that the both of the motion have, or the both of the wave have same frequencies and they both have same direction, in which I'm considering the direction as a x-axis. So you have to find uh, like what's happened when they superpose. So let me write it here. From principle of superposition, we have like such that with these two wave we get a single wave which actually look like x is equal to something a, and I don't know how it's look, but it will be something like a sine omega t plus delta. And one more thing is like x is equal to something x1 plus x2. So this is actually from the principle of superposition, x is equal to x1 plus x2. I am assuming that because these two wave of the is the function of sine wave. So also when we considering the superposed conditions, so I am assuming that we get an equation of sine wave with different phase difference and with different amplitude. So now let us see, is it, we have to like I am just writing it this analysis. I actually don't know it is true or false. So let's see, and let's check with the actually the principle of, from the principle of superposition. So it is actually x is equal to x1 plus x2. So let's write the both of the equations here. So here we will get A1 and sine omega t plus A2 sine omega t plus phi, because our second motion has a equation A2 sine omega t plus phi. Now what we have to do, we have to just solve this equation, right? So what can I do? I just open it with like sine of A plus B. I hope you all know that sine A cos B cos A sine B. So let's start writing A1 sine omega t plus A2, and let's open this. So it will be like sine omega t cos phi plus cos omega t sine phi. Right. I hope it will be clear to all of you. Now, what I'm trying to say here is, let's try to simplify this equation. So I may write this equation as A1 sine omega t and just multiply these two equations. So we can get to something like A2 sine omega t cos phi plus A2 cos of omega t sine phi. Now, what else we can do? Basically, if you look at here, you can do one more thing is uh, A sine omega t, basically A1 sine omega t, A2 sine omega t. If we like, I can write this expression as, look at here. This is actually whole is our x, right? And what else we can do here is, I am considering that this whole of the equations, right? I'm taking as a vector sum, right? Because these values, with the help of these values, I can write it as root under a1 square plus a2 square plus 2a1 a2, and there will be some cos of del, which is actually I'm writing here what it is, so it will be clear to all of you. And then there is something sine omega t plus theta, we can say, right? So now let me tell you how I write this expression from there. So let me draw here a figure. So let us assume this is actually our amplitude, which is actually A1, right? And wave in this direction, basically all in x direction. And what I'm assuming, the second wave has a phase difference of, has an amplitude A2, right? And has a phase difference of actually phi, right? And here the both wave, I'm writing it as like del, and I am assuming that del is actually the phase difference between two waves, right? So I hope this thing will be clear to all of you. Now what I have to do else here, look at here, how can we find this phi angle? So if I take the perpendicular distance from here, so how we can write the tan phi as? So so the tan phi is actually, and this is actually del angle. So this by this length, right? P by B. So we can write A2 sine del divided by, and there will be A1 plus A2 cos del. So this is actually our phase differences, right? I hope it will be clear to all of you what I'm trying to say. In later on, we also look into some problems. So it will be easily and clear to all of you, right? So look at here. I'm just taking the two, मैं देखो मैं ऐसा बताता हूँ कि मैं दो सिंपल हार्मोनिक मोशन कंसीडर कर रहा हूँ, जिसके दोनों के जो डायरेक्शंस हैं वो सेम है, दैट मीन सेम डायरेक्शन में ऑसिलेट कर रहा है, एंड दोनों की फ्रीक्वेंसी सेम है, राइट? तो क्या होंगे कि वेव एक दूसरे को सुपरपोज कर रही होगी, राइट? तो हमें पता करना है, हमें फाइंड करनी है कि जो नेट एम्पलीट्यूड होगा और जो नेट जो जब जब दोनों वेव्स ने सुपरपोज किया तो हमारी नेट इक्वेशंस क्या आ रही हैं, राइट? तो फ्रॉम दिस प्रिंसिपल ऑफ सुपरपोजिशन, वो सीधा यही कहता है दोनों को ऐड कर दो, right? So when we add the both of the equations, so we get to a result जो कि इस वेक्टर सम से आ रहा. Like I'm considering that we have a A1 amplitude with the zero phase difference and with a del, or you can say five phase difference, we have a A2, right? And when I'm trying to find this phi, if I am, you can write it as some else angle, or you can say this as actually theta. Because I am considering somewhere else, so you can assume this as theta. Or else you can say this angle as theta, so you can find that tan theta is equal to A2 sine del, which I'm calculating because this amplitude is A2 and this angle is del. So this component is actually A2 sine del and this component is actually A2 cos del. And we have to write like P by B. So it will be A2 sine del divided by A1 plus A2 cos del. I hope it will be clear to all of you. Let's look into some problem and then try to clear this thing. So the first problem is actually x1 is equal to, we have a first wave which is actually 3 sine omega t plus 20 degree and x2 is equal to 4 sine omega t plus 180 degrees. Look at here, 110 degree, right? So we have actually two motion given here, basically two equations of motion given here. And we have to find the, because these two waves are superposed, so we have to write the equation of superpositions, right? Now, when we look into this equation, we can conclude two things. The first thing is the both of the equation have same frequency because the both have same omega. And the second thing we can conclude is both of the wave is actually oscillating in same direction, which is actually x direction, right? So the things what we have to do here, we have to like how to approach and how to solve this problem. So let's take the wave which is actually had smaller phase difference in a first. So it will be like 3 and it has an amplitude of 3 meter or centimeter, whatever it is. And the next thing is the difference, the phase difference between the two of the wave is actually 110 degree minus 20 degrees is actually 90 degree. So let's take the second wave, which is actually somewhere here. And this is actually our del, which is actually 90 degree. Now let's connect these of the two. This is actually our amplitude of superposed, right? And this is actually 4. So it is actually the 90 degree. So we can directly say our A superposed is actually nothing but A1 square plus A2 square, which is actually equal to 9 plus 16, which is actually 5. Yeah, we can directly say. But the next thing we have to keep in mind here is we have to write the equation. So it will be like x is equal to A sine omega t plus phi. Now, how to calculate the phi? How to calculate the phi? So we already know, like the tan phi is actually is equal to A2 sine del. So it will be A2 sine 90 degree divided by A1 plus A2 cos del. And since here del is equal to 90 degrees, so I'm just writing directly. So this will be like A2 by A1 because this term is 0 because cos 90 is 0. So A2 by A1. And what is actually A2 and what is actually A1? So it will be 4 by 3. So our phi is actually tan inverse of 4 by 3. And it is actually nothing but 53 degree. Right. So when we write the equation of superposition, so it will be like x is equal to 5 sine omega t plus 53 degree. I hope it will be clear to all of you what I'm trying to say. Now, the next thing I'm gonna talk about is now this is actually our case one in which I'm considering that the both of the equations have same frequency and both are moving in the same direction or both are oscillating in same direction. Now I'm assuming that, or I'm taking the case two in which superposition of two perpendicular SHM with same omega. What I'm trying to say? I am trying to say that there is actually two uh, motion which is actually perpendicular, which has a direction is actually perpendicular to each other, and but the both of the equation have the same frequency. Okay, try to understand. Basically, let me tell you again what I'm trying to say. There is actually two simple harmonic motion is actually happening, but both is actually happening in perpendicular direction to each other, but both has same frequencies. Actually, let me write the equation of the two waves so you can connect it with. So what I'm trying to say, we have got two motion, which is actually x is equal to a1 sine omega t, you can say, and but the other motion is actually perpendicular in direction to the other motion. So I'm considering in the y direction. You can also consider it in z direction also. So z is equal to a. Let me assume some other amplitude a2 sine omega t plus phi. So these are the actually two simple harmonic motion, two equation of simple harmonic motion, which are actually perpendicular to each other, right? So both of the equation is actually perpendicular to each other, right? Or if you want to, let me insert here. If you want to express this thing in, so you can also, okay, let me insert here. Okay, that's fine. So what I'm trying to say you, this is actually our y-axis, and this is actually our x-axis. And in x-axis, we have an amplitude of a1, and in y-axis, we have an amplitude of a2. So you can express the motion in such way. Our first, which is actually I'm considering it as first, and it is considering it as second. So our first simple harmonic motion is actually occurring in x direction with an amplitude of a1, and the second one is actually happening in the y direction with the amplitude of a2, and but the both of the wave have same frequencies, right? So again, from here we can write r is equal to, which is actually distance, or you can say amplitude. So it will be like x square plus y square, because both of the equation is actually in perpendicular way. So we can write r is equal to, what is our actually x? So x is equal to a1 sine omega t, and a2 is equal to and x2 and y is equal to a2 sine omega t plus 5. So here we can write x square is equal to a1 square sine square omega t, and plus a2 as, and basically y as a2 square sine square omega t plus 5, right? Now, in this case, basically we have to deal with some kind of phase difference, because in this case, phase difference is important. And in upcoming class, you are gonna learn, like in higher classes, you're gonna learn like how it's come was in, but in this case, in standard 12, you actually you just have to focus on the main result, right? So let's take the case A here, which is actually nothing but when our phase difference is actually, here is like phi, right? The both of the equations with a phase difference of phi. So when phi is actually the even integral multiple of pi, that means 2n pi, or you can say n is equal to 0, 1, 2, dot, dot, dot. So our phi is actually varying as 0, 2 pi, 4 pi, है ना ऐसा. So in this case, if our phase difference is even integral multiple of pi, so look at the expression x is equal to a1 sine omega t and y. So we can write same like a2 sine omega t, right? So from this equation, from this equations, we have a r which is actually is equal to root under a1 square plus a2 square and sine of omega t, because sine square omega 2 sine square omega t, so it will comes outside. So we can also write it here as r is equal to a sine omega t, where a is actually nothing but a1 square plus a2 square. I hope it is clear to all of you. Now the first thing you have to keep in mind, which is actually motion here is SHM with an amplitude of a square is equal to a1 square plus a2 square. अब यहाँ पे आपको पता चलना चाहिए कि इक्वेशंस ऑफ ट्रेजेक्टरी कैसा है, राइट? So the second thing, the second information you have to keep in mind is equations of trajectory. So it is actually is a straight line with a positive slope, and it is actually a2 by a1 into x, right? And if I'm gonna let me draw the figure here, let me insert this again. Okay, so let me draw the figure here so I can elaborate you. Let me take some other color and then insert. Okay, so our actually I have to draw this straight line, but I think how can I draw this straight line? Wait, I have to insert. Okay, so this is actually representing the motions, right? A2 by A1, because this is actually the equation of our trajectory. Y is equal to A2 by A1 into X. And here like T is equal to 0. Here is like T by 4, right? And in this direction, we have the motion is actually. Now, this is the first case in which our phase difference is the even integral multiple of, or the even multiple of the pi. Now, the case B we can discuss here is if phase difference, give me a moment, please. Okay, so if our phase difference is actually the odd multiple of the pi, like 2n plus 1 into pi. So here they also n is 0, 1, 2. You can take any value. So in this case, or if I'm gonna tell it here, like pi, 2 pi, 3 pi, is there equal phase differences on? So in that case, I'm gonna write the equation which is x is equal to a1 sine of omega t, and y is equal to minus a2 sine omega t, because pi plus sine pi plus x is actually minus sine x. So minus sine omega t. So the same thing is happening here. Our equations of motions is actually r is equal to root under x square plus y square. So we can write it here a1 square plus a2 square sine omega t, and it will be equal to a sine omega t. Now, now what about the equation of trajectory? So in this case, the equation of trajectory is actually is equal to y is equal to minus a2 by a1 into x, and also in straight line. These are actually experimental things, so you have to keep this thing in mind. If you do the experiment in class or school, it will be easy to understand, right? क्योंकि अब मैंने यहाँ पे वो लिख दिया ना इक्वेशन ऑफ ट्रेजेक्टरी, बट यू हैव अ क्वेश्चन इन माइंड कि हाउ इट्स कम फ्रॉम, like from where it's come, why I'm assuming that, but these are actually experimental aspects, so you have to just, if you do the experiment in your school or anywhere else, so you can find this, that the equation of trajectory is a straight line with a slope of a2 minus a2 by a1. So let me draw the things here is, okay. So this is actually our equation of trajectory, in which we can call it like at a t is equal to 0, we have x is equal to y is equal to 0, and vx is equal to actually a1 into omega, and vy is equal to actually a2 into omega, in this direction and in this direction, right? So this is the thing that we have to keep in mind. So here the each and every single cases are defined as defined as with the phase difference. कि phase difference कितनी है उसके according चीजें डिफाइंड हो रही है. एंड वन मोर क्वेश्चन यू हैव लाइक आपके दिमाग में चल रही है कि इक्वेशंस ऑफ मोशन क्यों ही स्ट्रेट लाइन होगा, कैसे होगा. सो आई एम अगेन टेलिंग यू दीज आर एक्चुअली एक्सपेरिमेंटल थिंग्स. बट व्हेन यू सॉल्व द प्रॉब्लम सो यू हैव टू जस्ट लाइक कीप दिस थिंग इन माइंड कि स्ट्रेट लाइन होगी विद द if the phase difference is the even multiple, so trajectory straight line होगी and with the slope of a2 by a1. and अगर odd मल्टीपल है पाई की सो स्ट्रेट लाइन नहीं होगी बट जो स्लोप आएगा वो आएगा -a2/a. राइट. नाउ लेट्स टेक द केस C in which phase difference is exactly pi/2. So in this case our x is equal to, or you can derive it from here, like if you wanna look like how it's from the equation of trajectory comes, so you just divide this thing. So you get like y by x is equal to a2 by a1 or a1 by a2. So you get the equations of motion. But I'm again telling you these are actually experimental aspect क्योंकि आपको ऐसा like चीजें when you do the problem, so you can analyze it from here. If I divide these two equations, so I get the equation of trajectory, right? So you can also do in this way. Now here when the theta is actually pi/2, so our x is equal to a sine omega t. And the second one is like y is equal to a2 cos omega t. Right. So equations are something r is equal to root under x square plus y square. So from here we get a1 square sine square omega t plus a2 square cos square omega t. I hope it will be clear to all of you. Right. Now, when we talk about the equations of trajectory, so what my suggestion is just divide it both side by a1 and square and add the both of the equation. So what you will get x by a1 square plus y by a2 square is actually is equal to 1. So basically x square by a1 square plus y square by a2 square is actually is equal to 1, and this is actually the equation of ellipse. Right, it is actually the equation of ellipse. Okay, जो equations of ellipse होती हैं वो क्या होती हैं? x square by a1 square plus नहीं x square by a square plus y square by b square is equal to 1, and this is actually of the same form. Right, so you can think in this way. Okay, now let's talk about its motion. So the motion is actually periodic but not as a jump. And let me draw it here or insert it here the things. Let me take some next color. Okay, that's fine. And I have to take some other color and we have to insert the ellipse. The first thing I have to insert here is, okay, and now I have to enter here the ellipse. Okay, so this is actually our trajectory, something look like, in which this is actually our x-axis, this is actually our y-axis, and x is equal to a1 sine omega t and y is equal to a2 cos omega t. Vx is equal to a1 omega cos omega t and vy is equal to minus a2 omega sine omega t. So we can write it here at time t is equal to 0. We have like equation x is equal to 0 and y is equal to a2. And we have vx is equal to plus a1 omega and vy is equal to 0. So this thing we can write it from this expressions, right? Now the next thing we have to discuss here is about the, if like in this case a1 is equal to a2, so our equations is actually, let me write it here, the spatial case of C when A1 is actually is equal to A2. So x square plus y square is equal to A square. Equations of trajectory is actually circular, right? And the motion is again periodic, but not essential. Right? So you have to keep this thing in mind. Now the last things जो हमने सारी तो डिस्कस कर लिया, बट एक चीज हमने अभी भी डिस्कस नहीं करी है, एंड वो है लाइक इफ यू लुक एट फ्रॉम द अपसाइड, हमने सारी फेज डिफरेंसेस देख लिया, लाइक अगर फेज डिफरेंस इवन मल्टीपल हो, है ना, अगर फेज डिफरेंस ऑड मल्टीपल हो तो ऐसा होगा, और अगर फेज डिफरेंस पाई/2 का हो तो कुछ ऐसा होगा, अगर फेज डिफरेंस पाई/2 का हो और दोनों एम्पलीट्यूड इक्वल हो तो इक्वेशंस ऑफ ट्रेजेक्टरी सर्कुलर होंगी, मोशन पीरियोडिक होगा बट सिंपल हार्मोनिक मोशंस नहीं होगा। तो ये सारी चीजें जो हैं हमने डिस्कस करी। नाउ द व्हाट अबाउट द सम अदर एंगल, लाइक अगर फेज डिफरेंस पाई/4 का हो, 3 पाई/4 का हो, या फिर कोई और एंगल का हो जो कि ना ही वो एंगल इवन मल्टीपल ऑफ पाई हो, ऑड मल्टीपल ऑफ पाई हो, और ना ही वो पाई हो, पाई/2 हो। So how can you basically term it as, right? So let me write here the case 4 actually. And the case 4 is actually when our phase difference is not equal to even multiple of pi, odd multiple of pi, and pi/2. So the path is actually elliptical with different orientations. This thing just you have to keep in mind. And the second thing is motion is again periodic but not as a chain. Motion is periodic but not as a chain. Right? Here the motion is, or you can say here one more thing, a rotating ellipse. I hope it will be clear to all of you कि चीजें क्या क्या हमने पढ़ी ऑसिलेशन में। स्टार्टिंग में हमारा मेन टारगेट जो था वो था टाइम पीरियड कैलकुलेट करने का, जिसमें हमने फोर्स मेथड सीखा, एनर्जी मेथड सीखी, देन हमने बहुत सारे सिस्टम पे काम करे, देन उसके बाद हमने सिंपल पेंडुलम, फिर एंगुलर सिंपल हार्मोनिक मोशंस देखे, फिर एंगुलर सिंपल हार्मोनिक मोशंस में हमने सिंपल पेंडुलम, कंपाउंड पेंडुलम और भी बहुत सारे सिस्टम पे काम करी। देन उसके बाद हमने फ्री वाइब्रेशन, फोर्स वाइब्रेशन, डैम वाइब्रेशन एंड ऑल पे उसके एम्पलीट्यूड कैसे वैरीज करते हैं, एनर्जीज कैसी वैरीज कर रही होती है, वो सारी चीजें सीखा। एंड एट लास्ट हमने सुपर पोजिशन ऑफ द टू वेव्स सीखे हैं, जिसमें हमें ये पता चला कि अलग अलग केसेस में अगर अलग अलग सुपरपोज्ड इक्वेशंस आती हैं, अगर अगर दो वेव्स सेम डायरेक्शन में सेम फ्रीक्वेंसीज के साथ मूव कर रही हैं तो उनका सुपरपोज होने की इक्वेशंस अलग तरीके से लिखी जाएंगी। अगर अगर बेसिकली फ्रीक्वेंसी सेम है और बट बोथ आर मूविंग इन द परपेंडिकुलर डायरेक्शन, सो उसकी क्या अप्रोचेज है, उसके लिए हमें फेज डिफरेंस देखना होगा कि फेज डिफरेंस इवन मल्टीपल ऑफ पाई है, ऑड मल्टीपल ऑफ पाई है, या फिर पाई/2 है। अगर पाई/2 है तो अगर दोनों की एम्पलीट्यूड सेम है और इक्वल है, बेसिकली सेम है और डिफरेंट है, और अगर कोई और एंगल है तब क्या होंगी, है ना। सो दीज आर दी थिंग लाइक वी हैव टू डिलीट इन दिस चैप्टर। सो बेसिकली ये जो चैप्टर है ऑसिलेशन यहाँ पे होती है इसकी, एंड आई होप यू लर्न अ लॉट्स ऑफ थिंग बाय दिस चैप्टर। So thank you. From next class, we are going to start our new chapter, which is actually we are going to discuss about some waves, in which like transverse wave and longitudinal wave. So okay, that's all for the today's class. Thank you.